In maths, we plot our graphs on a Cartesian plane. A Cartesian plane is a flat surface that goes on forever in every direction, and we use two axes to do our plotting. We use an x-axis, which runs horizontally, and a y-axis, which runs vertically. The Cartesian plane is separated into four quarters. This top right hand corner here is called the first quadrant, and in this quadrant x and y values are both positive. In the second quadrant on the left, x's are negative and y's are positive. In the third quadrant, x and y are both negative, and in the fourth quadrant, only y is negative. One of the things we do with Cartesian coordinates is plot graphs. So I'm going to start off by plotting a few points. Anywhere on the Cartesian coordinate system can be plotted by using just two numbers. In this case, we're using x and y, and often x and y are used to plot points. So I'm going to find a point up here, which I'm highlighting with a cross. That point is 4 across in the x direction and 3 up in the y direction. So we write that point as 4, 3, which means 4 in the x direction and 3 in the y direction. If I pick another point like this one over here, then it is 4 or minus 4 in the x direction and 2 up in the y direction. So its point is written as minus 4 for x and 2 for y. If I was to pick this point over here, I would label that one as minus 6 because we've come 6 across to the left in the negative direction for x, and nothing up because we have not moved up at all or down, so the y component of the point is 0. If I pick another point over here like this one, I would write that one as 0 because I haven't moved left or right, and 4 because we've gone up by 4 in the y direction. Every point on the coordinate system can be labelled with two values, an x and a y, even those that are in between. So a point about here would be labelled as 2.5 minus 2.5. There are a lot of real-world examples of linear graphs. Let's have a look at a few. In this first example up here, the temperature of the heated water depends on how long you heat it for in a linear fashion. It's a linear graph. In this example here, the more you price your item, the less people buy it. In this example here, the more hours you work, the bigger your wages go up, or the more wages you get. And in this example, the price before tax and the price including tax are related by a linear graph. While I'm teaching you about linear graphs, we'll be using x and y, so x and y as our two coordinates. You can use dollars and numbers, or you could use time for T for time and temperature, capital T for temperature, or H for hours and W for wages. But to keep it simple, we will be just using x and y all the time. Here are some examples of linear graphs. A linear graph will have a y and an x plus some numbers. This one is y equals 3x. Another one is y equals 2x plus 6. Another example, y equals minus 4x minus 1. And another example, y is equal to x. They all have the form, or look like, y equals mx plus c. Y equals mx plus c is the general form of a linear graph. When plotting a graph, you use the formula, in this case y equals x plus 2, to fill in some values on a table and then use those points to plot the graph. So let's start off with the graph y equals x plus 2. It's telling me that whatever x is, I need to add 2 onto it to get the y value. So if I start with minus 3, adding 2 onto that, I get minus 1. So I'll just continue adding 2 onto all these numbers, and you can see that I end up with pairs of numbers that I can plot. So now I'm going to plot the points. I'm going to start off with this pair of numbers here, minus 3 and minus 1. So coming up to the origin, which is in the middle, I go minus 3 to the left for x, minus 1 down for y, and plot my point there. For the next point, minus 2 and 0, start again at the origin, move 2 to the left for the x direction, and don't move at all up or down, and plot my point. The next point is minus 1 and 1. So again, starting at the origin, minus 1 in the x direction plus 1 in the y direction gives me this point here. You can already start to see that a line is forming, and it is a straight line by the positions of the x's. So let's just keep going quickly through it. The next point is 0 and 2. The next point is 1 and 3, so 1 across and 3 up. And the next point is 2 and 4 and 3 and 5. So now I've plotted my points, I just need to draw a line through them to make the graph. And there it is. So this line that I've sketched is actually the line of y equals x plus 2. Every point on this graph, every point along this graph follows this rule. If you pick a point that isn't on that graph, like this one here, it does not follow the rule. It has to be on this line to follow this rule. When we plot a graph, some of the points lie on the line or follow the rule, and some points don't. So if I started off with a point, say 3 and 2, that would be 3 across, 2 up, and this point here does not lie on the graph. It does not follow the rule. But if I picked a point minus 1 and 1, and went minus 1 and 1, I would get this point here, which is actually following the graph, so it lies on the line. You don't need a graph to check if a point lies on the line. You can use its formula. So I'm going to use this point 1 and 2 and see which of these lines it lies on. You do that by just substituting the x value and see if it makes the same y value as the point. So y equals 2 times x, which is 1, minus 1. That's equal to 2 minus 1, which is 1. And that does not match the 2. So this point does not lie on that graph. Let's try the second one. Y equals 1 plus 1, so substituting for x, I get 2, and that agrees with this point here, because y is 2 when x is 1. Substituting in for 1 for x here gave me a value of 2 for y. It agrees with the point. So this point here, 1 and 2, lies on this line. This point 1 and 2 does not lie on this line because I didn't get the correct y value. I got 1. I needed to get 2. So just before we finish, a few quick facts about linear graphs. How long is a line? Well, technically a line is infinite in length. It goes on forever in both directions. If it wasn't a line, we'd call it a line segment, which is a small part of a line. The other one that's a bit tricky is that how wide is a line? Again, technically a line is of 0 width, but we can't draw lines of 0 width, so they always end up being a little bit fatter than 0. How many points make up a line? A line is made up of an infinite number of points, all crammed together, so much crammed together that they look like a line. How many points do you need to sketch a line? Well, 2's enough. 2 points for a straight line is enough to get the line correct. 3's a good idea though, in case you muck one of the others up. You can easily find out if there's a mistake. What facts are important for a line? So when we're looking at lines, there are three things that we're interested in generally. First of all, where it crosses the y-axis, where it crosses the x-axis, and how steep it is. If I was walking up this line, I'd like to know how hard it's going to be.